Hello there, Algebra 1A, and welcome to Lesson 3.6, Solving Proportions Using Cross Products. We are going to look at a new way to solve proportions today. Some of the things we're going to go over are cross products, scale drawings, that's used for these as well, scale models, and scale. Let's get into the business right away. Cross products property. The cross products of a proportion are equal. Okay, we are going to work with cross multiplying today, which really isn't too bad. Example, essentially what's going on here is we're going to be taking 6 times 10. 6 times 10. And on the other side, we're going to take 5 times 12. 5 times 12. And we call that the cross products. So as long as the numbers aren't 0, the denominators, A and D is equal to B and C. So AD is equal to BC. Cross multiplying. That's what it's all about. Okay, so solving proportions using this method. I know we looked at a little different method yesterday, but this is how easy it is. If you have an example like 5 over y is equal to 15 over 75, we're going to do the crisscross. 5 times 75. Okay, and y times 15 essentially becomes 75 times y, which is 375. On the other side, we have 15y. And then to divide, or to solve that, we're just going to divide each side by 15. So we're dividing by 15, 375 over 15 gives us our answer of 25. So the solution to that simply is 25. Cross multiplying, pretty neat. This does come in handy solving real world problems. Okay, if you're ever looking to build a house and you have to scale things with certain dimensions, it can be helpful. Or feeding plants. You need to mix 3 tablespoons of plant food with 16 ounces of water. It takes 80 ounces of water to feed all your plants. How many tablespoons are needed? So they set up a proportion for you. We know that the regular plants are 3 to 16. We're not sure about the amount of plant food we need, but we do know that we have 80 ounces of water. Okay, so when we need to set up the ratios, remember that we have plant food up top, and it's equal to the other plant which we're trying to find. Once you have it set up, it's as easy as cross multiplying. So we have our proportion, cross multiply 3 times 80 and 16 times x, 3 times 80, 240 is equal to 16 times x, and we can divide each side again by 16 to then get our solution of 15. So we're going to need 15 tablespoons of plant food for our 80 ounces of water. Okay, let me show you some more examples here. Okay, so solve the checkpoint, or the checkpoint here is, again, cross multiplying. So we need n, we're just going to cross multiply. 5 times 45. 5 times 45 is 225, and that's equal to 25n. Dividing by 25 tells us that 9 is equal to n. Here is a challenging one too. Pay extra attention. When we multiply to a binomial, or to a term like the denominator here, you're going to need to be careful. 6 times the quantity. This is 6 times b minus 2 is equal to 3b. Now we have to distribute. So 6b minus 12 is equal to 3b. And you're going to need to use some of your old skills. Minus 3b is going to then be 3b minus 12 equals 0. You're going to need to add 12 over. So 3b equals 12. And then divide by 3. So there's a good bit more to that type. Definitely have that example down. Okay. Example 2, suppose it takes 120 ounces to feed all the plants. Well, let's look back at the original ratio, 3 to 16. okay, is equal to, we don't know the tablespoons, over 120. Okay, cross multiplying, 3 times 120 is 360, is equal to 16 times x. Divide that by 16, and we get 22.5 is equal to x, or 22.5 tablespoons. Okay. Scaling models. This is the other use of proportions and ratios. Really useful if an architect. Sometimes you make models of the big skyscrapers you want to make. So the school is 50 feet high. The ratio of the model to the actual is 1 foot to 75 feet. Okay, so what we want to know is, if we have a little model, what is the actual size that we're going at? So that is what a scale does. So our original scale is 1 to 75. 1 foot is 75. The school itself is 50 feet high. Okay, so we have 1 over 75 to the height over 50. We are going to do our cross multiplication. So 1 times 50 is equal to 75 times the height. 1 times 50 is just 50, and we're going to divide that by 75, and we get about 0.26, or 2/3. Math enter is what the height of our model would need to be then. Okay, so the height of the scale model is 2/3 of a foot, or as far as inches is concerned, if we multiply that by 12 for inches, that's where it gets confusing. So since it's in feet to inches, we're going to multiply by 12 to get it in inches. Okay, so let's look at this next example, our last one here. Suppose the ratio of the model to the actual school is 1 foot to 100. So we have 1 over 100 this time, equals, we want to know how high our model should be, and we know that it is still 50 feet tall. Cross multiplying, 100h is equal to 50. Divide by 100. The height then is 1/2 feet, or that's going to be 6 inches. Okay, definitely try these problems out. That will be in the 3.6 practice. And good stuff, guys. Ratios, proportions, cross multiplying.